Kibsi is a low-code computer vision platform that makes it so that any customer can take live streaming data and turn that into actionable data. In the old days, it required a lot of expertise from PhDs and other academic types in order to build computer vision models, deploy the infrastructure, and manage the complexity of these real-time applications. With Kibsi, we make it a simple drag and drop operation. A user can go into our application and literally take the detections that they're interested in, people, vehicles, objects of various types, and build out a domain model from that. And that domain model will be filled in automatically by Kibsi via observations that it sees.
Kibsi empowers all kinds of use cases. For example, a manufacturing customer could understand the flow of goods throughout their manufacturing line and understand bottlenecks or process violations or interventions from operators. Or a supply chain customer is using Kibsi to understand loading docks and the time it takes to load and unload a truck, or the number of pallets that come on and off a truck. And customers with dangerous environments can use Kibsi to understand safety. For example, if workers are complying with PPE and other safety protocols, you can do that in a way that's contextualized to the actual customer's environment. So there's all these different use cases out there, and they all involve the same few concepts, which is detecting objects, putting them into context, tracking them as they move, and being able to build business rules around them. And Kibsi converts the physical world into data to enable these kinds of applications. Without Kibsi, customers are left to either build these solutions on their own from very low-level building blocks that require a lot of assembly.
Our web application is completely AWS native. We use Lambda, API Gateway, and DynamoDB for a serverless experience, which really accelerated the development of the application. We pair that with Aurora Serverless for long-term storage and more traditional SQL-like, without having to have the burden of managing that sort of infrastructure. Our runtimes are built with containers and deployed via EKS. This is really important for us because it gives us the portability we need in order to run the runtimes, which are responsible for the real-time video stream processing, real-time inference, and data streams, both in the cloud and at the edge. AWS IoT Core provides a really critical link between our runtime environments, which might be at the edge, and our cloud environment, allowing us to have secure command and control.
For actual streaming from cameras 24/7 and doing inference, we use Kubernetes with EKS running on GPU-backed EC2 instances. And this lets us build an environment that is totally transparent to the customer. They just push the button in our UI to launch a new workload, and we spin up containers in EKS that'll stream from that camera, that'll do all the real-time inference, that'll put all that together into a data model and into an outcome. And then customers can access those outcomes through our API layer. And so it fits together really nicely, lets us scale as we onboard customers without a big upfront infrastructure expense, and it lets us minimize all the work we're doing to manage and maintain infrastructure, as it's pretty much all automated away for us.